Hi, if we've not met before, my name's Joel Gibbons. Welcome to Assignment 2 for EDME 369. This is my prop box that I would use for Stage 2 learning in a Year 3 classroom. My prop box addresses number sentences with unknown values. But before we get to that, let me ask, what do you call a fish with no eye? A fish! To begin our journey in completing number sentences with unknown values, we have Prop 1, a book I created with the help of my early learners at Little Coasties Kindergarten, titled 10 with No Friend. In the book, we meet a Martian named Glenn who lived on the planet 10. His whole life was wrapped up in everything being 10, so that when he moved to a new planet where everything was a little bit different, Glenn found it hard to settle in. The aliens on the new planet had different numbers, like 2, 8, 1, or 9. The conclusion for this book brings home the relevance for algebraic number sentence work. Glenn finds a way to feel at home on his new planet, using the equal sign, as Glenn calls out, "It's the same as!" and lists a pile of number sentences which all the numbers add up, or are the same as, or are equal to 10. Our next prop or activity uses concrete material to follow the theme that the equal sign means the same as. It also addresses the syllabus content in the patterns and algebra stream, where a student selects and uses appropriate mental or written strategies to solve problems, and also checks the accuracy of a statement and explains the reasoning used. The teacher in this circumstance uses buckets and bags of pegs to help illustrate how the equal sign means the same as. For an effective teaching time, it would be best to have the teacher model the activity in its entirety so that students have a visual representation of what is required of them. The concrete materials consist of several buckets that have addition number sentences on them, using the numbers 7, 3, and 5 in a variety of orders. The objective is to have the amount of pegs on the inside of the bucket that is written on the outside. However, in the glued shut bags, we don't have any 7s, 3s, or 5s. To complete the activity, students must solve the number sentence, recreate the number sentence, finding the right amount of bags, and then they are to rewrite the number sentence. For example, 7 plus 5 plus 5 is equal to 9 plus 6 plus 2, which equals 17. This is a time that as a teacher I would make an assessment for learning, identifying if students are capable of addition and are able to understand that the equal sign means is the same as. This activity also lends itself to gearing up, where teachers are able to make the initial number sentence a subtraction, multiplication, or even a division problem. From here, our next prop introduces addition and subtraction number sentences with missing values using concrete materials. We focus on syllabus content that students are able to add 3 or more single-digit numbers, that students can choose and apply efficient strategies for addition and subtraction. They can use concrete materials to model the addition and subtraction of 2 or more numbers. That students check the accuracy of statements. They can create number sentences by calculating missing values. Use equivalent number sentences involving addition and subtraction to find unknown quantities. For this exercise, our concrete materials consist of weighing scales, bench scales, a basket of weighted bear toys, and also unknown weighted bags of sand. The objective here is for students in groups of up to 3 to use the weigh scales to calculate the unknown property of the bag of sand. Firstly, have the students write out the number sentence. For example, 8 plus blank equals 3 plus 3 plus 12 plus 12, which is also 30. For this exercise, students may need to use inverse operations to work out the blank. In this case, the number sentence could be rewritten as blank equals 30 minus 8, which equals 22. That's the weight of the bag of sand. Once students have calculated the sandbags, they are to check their results with the digital scales. Due to the accuracy of the weigh scales, as positioning of the weighted bears can affect the result, it is important to inform the students that being up to 5 grams out is still really good, as it is hard to be precise with these weigh scales. However, use this time as the students weigh the sandbags to do an assessment on learning. Check that the number sentence is accurate, whether students have used inverse operations to work out the data, or whether they have used addition and or subtraction effectively to analyse the unknown quantity. Now that we have created interest and played with some concrete materials, we have a whole class activity. We are looking at family number sentences, specifically how numbers relate to one another, reading from left to right. In this activity, we cover syllabus content that students are able to use the equal sign to record equivalent number sentences involving addition and subtraction, multiplication and division. Recognize and explain the connection between addition and subtraction. Recognize and explain the connection between multiplication and division. Demonstrate how addition and subtraction are inverse operation. Demonstrate how multiplication and division are inverse operations. Recognize and use the symbols for addition, subtraction, multiplication, and divided by signs, and the equal sign. And also check number sentence to determine whether they are true or false. The way this activity works is that the teacher writes 4 number sentences that use the same 3 numbers. For example, 2, 5, and 7, leaving a blank space in the section provided. It is then the student's job to identify what sign is appropriate for the placement in the blank space. For 2, 5, and 7, the options could read 2 plus 5 equals 7, or 5 plus 2 equals 7, and 7 minus 2 equals 5, and 7 minus 5 equals 2. As a class, decide where the placement should go. At the bottom of the poster is the rules for the signs, reading the plus sign means put together with, the minus sign means with an amount taken away, the time sign means put in groups of, divide by means separate into blank amounts, and equals meaning it's the same as. Throughout the weighing activity, we see that using inverse operations is an effective method in calculating unknown quantities, which we will look at in more detail in a later activity. Before then, our next activity uses ICT to help students rewrite number sentences using money, covering syllabus content found more in the addition and subtraction strands, but I have found to be very helpful in assisting patterns in algebra content. The outcomes achieved is that students are able to represent money values in multiple ways and count the change required for simple transactions to the nearest 5 cents. They are able to calculate equivalent amounts of money using different denominations. They can model and apply the associative properties of addition to aid mental computation and perform simple calculations with money, including finding change and rounding it to the nearest 5 cents. We start with a word problem, where one character is purchasing items for 2 people. Students are to use their addition, subtraction, and number sentence knowledge to work out and justify who gets what change. This leads straight into our ICT exercise, courtesy of funbrain.com. The program asks students to work out the subtraction from a simple word problem and transfer it into an addition problem. Have students create a number sentence. For example, 100 minus 40 equals 60, which is the same as 20 plus 20 plus 20. Encourage students to look for a variety of methods to create the change. For example, 20 plus 20 plus 20 also equals 50 plus 10, or could even be 10 plus 10 plus 10 plus 10 plus 10. It is important to have students justify their answers. This helps in the assessment for learning, as students justify through writing down their work progress in the form of number sentences. Have students complete this activity on their own at least 5 times. It could also help productivity if you are able to remind students that this is the sort of maths that nearly every adult does every single day. Our next prop is called the Tower of Operations. As mentioned before, inverse operations can be a vital tool in calculating the value of an unknown. We are covering the syllabus content that students recognize that addition and subtraction are inverse operations of each other, and that multiplication and division are inverse operations of each other. For this activity, the rules are simple. For multiplication and addition, we move up the tower. For division and subtraction, we move downward as a class, with the direction of the teacher having given the 4 base numbers. Add or multiply the lower 2 bricks to achieve the result of the high brick. For gearing up, the teacher fills in 4 of the tiles anywhere on the grid, purposefully leaving some amount blank in order that the class needs to work up and down the tower to complete the task. Smaller versions of this table can be created for individual work, though this activity works well as a group. The next propbox activity is an ICT game for iPad. It has minimal syllabus content, though it is used to help maintain interest for students currently working with number sentences. The objective of this ICT iPad game is to analyse 2 sets of number sentence data. Students are then to swipe in the direction of the one with the highest value. If the values are equal, they are to swipe to the left or the right. Our final activity is brought to us from Cool Maths, an abstract activity where students use an ICT platform to be given number sentence problems. Using this ICT tool, we meet a frog named Freebit. His job is to eat flies that correlate with the number sentences. The position of the missing numbers varies from question to question, so inverse operations may be needed to solve some of the missing values. Freebit can only eat 3 wrong number flies before students need to start again. So this concludes my prop box for Assessment 2, studying EDME 369. My name's Joel Gibbons. It's been a pleasure to bring it to you. But before I go, let me leave you with this. How do you think the unthinkable? With an iceberg.